Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. So we are still in chapter 4. Right now is 4.5, which is moment about an axis. Right. So we have covered in the previous recording, in the previous section, which is moment about a point. So just to recap. Right. So we have covered moment about a point. Right, is this in the frame? Right, so if you still remember, hopefully you still remember the equation, right? So moment about points, so let's say MO equal to F times D, or in vector form, MO equal to R cross F, right? And that R is from point to force. So, right? R is from point to force. Right. That's the important information that we have covered in the previous lecture. Right now we are going into moment about an axis. So this is different. So moment about an axis. Right. So how is this different? Let's imagine in 3D, right? How to imagine this? Let's say, if is there an example? Yeah, if you have a wrench or something, right? A spanner or plier or whatever that you want to rotate something, right? Now, that object, or for example that screw or the nut, can only rotate about a certain axis. Can you understand? Meaning that if this is something like a bolt, it can only rotate this way, right? It cannot rotate this way. Meaning if it's like a nut or something, right? This is the only axis. It's about this axis here, right? This axis, it can only rotate about that axis. It cannot rotate about this axis or this axis, right? So meaning that in certain application, you only want rotation about a certain axis, because if you have a force about the point, then the way it rotates is like an orbit, right? It will be like this. Meaning it's actually have IJK, meaning it have three component of rotation, x component, the x component, y component, and z component, right? It's a combination. But if you apply force here, but this can only rotate this way, right? This way, meaning about z-axis, right? So it's moment about point is no longer what I want. I want a moment about an axis. So that's just the application, right? If you don't even understand that one, at least you understand how to calculate, and you can still calculate in the exam, right? So I just use some example here for those who will be using this to appreciate it, right? Alright. Similarly here, if you see the slide, there's a bracket. Bracket is basically like, for example, if you have like a rod like this and some bracket here, it can only rotate like about the rod here, like meaning in this case it rotates about this axis, right? Either this is the rotation, right? It cannot rotate this way, right? It can rotate around this, right? So that's an example. There's some example of we want only moment about an axis, a specific axis, right? So in terms of scalar analysis, basically the equation is the same. Moment about an axis is F times D. Right? However, okay, it's still the same. This D must be perpendicular. This D is perpendicular. Okay, let's just use. It should be perpendicular to force. If you still remember, perpendicular there, right? But in moment about an axis, the distance should be perpendicular to both force and axis, right? If you see the tire, the image of the tire, so you have the nut, so that's the axis of the rotation, right? The nut, the tire there, and then the force also is a line, so it have to be perpendicular to both, right? So if this is the nut axis, this is force, so you have to have this line which is perpendicular here and perpendicular here, right? I'm not sure how to show, but it should be perpendicular to both, right? But we will not deal with scalar analysis too much in this subchapter or section, because mainly question like this normally will need us to use vector, right? So that's why the discussion of vector is longer. So in the scalar is just say, okay, that's how you do if you need to. Alright. Okay, in terms of vector analysis, we have understood that if you go to the derivation, right, it will say that okay, moment about point we already established that one, right? But if you want to have a certain axis only, so it will have the moment of the point dot with unit vector of that axis. Hence you get, in the end, if you want to make it short, so it will have moment equal to u of the axis dot r cross f. That's in terms of the calculation. And in the slide they say this is triple scalar product. So sometimes they like to give name to things. So in this case, triple scalar product. What does it mean? Triple because we have 1, 2, 3. Scalar because it becomes a scalar. This is vector, this is scalar. Why? Because when you dot, okay, cross, we get still vector, but vector dot vector become a scalar, right? So triple scalar product. Right. So okay, the meaning first, right? This is unit vector for axis, right? The unit vector of the axis. So the question will give you, find the moment of this force about this axis of this line, whatever the question gives. For example, about line AB, right? Okay, the zoom is the focusing is problematic for the camera. Hopefully you can see. Alright, so this is about an axis. This is R is from axis to point and to force, and force is force, right? So meaning that if you have a certain axis, right? Say this is an axis, and then you have a force. So R is based on this equation is from axis to point to force. So from axis to force, for example. Or it can be like this, 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 right? So essentially it's from anywhere from the axis to anywhere on the force, right? So it makes our job easier, right? And this unit vector UA is unit vector of this axis, and F is F, right? If you already have the vector of each of these three, so this one can simply be solved by unit vector x, z, rx, ry, z, fx, fy, z. Right? So basically you just put the xyz of unit vector here, xyz of r here, xyz of f here, right? And then you just solve the matrix as before. However, there's no longer ijk. Do not put ijk up front here. Ijk has been replaced by unit vector. So you'll have number here, number here, number here. You'll just have number. Because why? In the end you have scalar, right? Do not, because some students, I'm not sure why, when they write this, they still write ijk up front here. That is totally wrong. Doesn't make any sense, right? All right. So, so we go straight to an example, right? So we have this example here. If you see the slide, there's like a hand gripping on something, right? So a force is applied to the tools as shown. Find the Find the magnitude of the moment of this force about x-axis of the value. What is that? But anyway, the question wants the magnitude of the moment of this force about x-axis, right? So by reading that, you have to understand several things. One is, okay, this question wants you to calculate moment about x-axis. So meaning it's moment of an axis. It's moment about an axis. It's not about a point, it's about an axis. And which axis is it? X-axis. Right? That's number one. Number two, the question actually says find the magnitude of the moment. So sometimes the moment can be vector, can be magnitude, right? So in this case, it wants the magnitude. Right? So make sure you know the question. Okay. So question, magnitude of moment about x-axis, right? So knowing that, and you know, okay, this is the equation, m equal to u dot r cos f. Now, in the exam, you have to write the equation first before going to the matrix. Do not write the matrix, because this one is not an equation. This one is a mathematical solution to this equation, right? So if you don't write this equation, suddenly it appears like this. So the static part is missing, right? So you lose some marks there. Do not do that. Alright. So what is needed is I need u, and f, and then I can just plug in and I can solve. Right. In this question, what is u? What is this one? Unit vector of x-axis. What is it? Unit vector of x-axis is I, right? Right, that's the unit vector of x-axis. Just like unit vector of y-axis is j, unit vector of z-axis is k. Right. What about r? So again, you have to identify what is the important point. In this case, important point is O and A. Right. It's not actually O, but it's the axis, right? But if you have any axis, the easiest point to use is origin, right? Because that's where one of the point on the axis. So that's the easiest one. So you use point O to point A, right? That will be your R, ROA, right? So what will be ROA? X-axis is 0, right? So 0i, and then y is 0.3 plus 0.3j, and then plus 0.25k plus 0.25k. So that's ROA, right? So you have 0 plus 0.3 plus 0.25, right? And then what is F? In this case, the question gives you in terms of alpha, beta, and gamma, right? So it's basically 200 cos 120 degrees I plus 200 cos 60 degrees J plus 200 cos 45 degrees K, right? So 200 cos 120, 200 cos 60, 200 cos 45. So right now you already expressed the three vectors that you need, U and R and F, right? So you just plug in here. Basically you plug in, you become I become what? Make sure you understand what you are putting, right? You should put 1, 0, 0. Do not put I, because that doesn't make sense. Because you notice that for R, you just put 0, 0.3, 0.25, right? You do not put ijk, you just put the number. Similarly here, for unit vector, you just put the number, do not put ijk, right? It's just like this, right? And then you have this 200 cos 120, 200 cos 60, 200 cos 45 degrees, right? And then you can solve just like before, right? It's basically if you use one, maybe if you use the closed method, right? So 1 this times this, whatever value there, and then minus 0 plus 0, right? Before it's ijk because here it's ijk. Right now it's 100 because it's 100, right? So that's how you calculate, and then you get the answer. Right, so you get positive 17.4 Newton meter, and it says they counterclockwise because it's positive k and not positive k. Alright, now the rotation, okay, how to understand this? The meaning is that's the value of the rotation, right? But the rotation itself is based on the u that you use. Because actually if you see it's what is the rotation about x-axis, if this is x-axis, right? If this is x-axis, right? It can rotate two ways, right? Either this way, it can rotate either this way or this way, right? Meaning clockwise or counterclockwise, right? So if you take u as I, meaning your thumb is already, you say, oh, thumb is I. Well, if x, y, z, thumb is I, right? So you'll get counterclockwise, right? So that's why here, when I use I get positive, that is counterclockwise. So that's why you see in the answer there is CCW, is counterclockwise. If you get a negative value, meaning it's actually negative I, meaning clockwise, right? Understood? Now, okay, we have another example. Actually, there's a attention quiz, the concept quiz. I think this is one is interesting, but it's because I cannot project it here, so please do remind in the class for me to discuss this concept quiz, the pyramid one, because that's important for you to understand. However, we go to the next problem, which is group problem solving. You have like a bracket and something there, so we'll try to do this one. Alright, so looking at the slide, so you know what I'm referring to. So group problem solving. So you have the bracket and something there, and then the question says, given that the force is F equal to 30 degrees, and then you have alpha beta gamma, and alpha beta gamma is already given 60 degrees, 60 degrees, 45 degrees, right? And then find the moment of F about AA axis, right? And AA is that axis down there. Alright, so here in this question there are some understanding that you have to understand to be able to solve, right? If you understand, it's very easy, right? Now again, from the question, first thing you have to understand the question. Okay, find the moment of F about AA axis, meaning, alright, it's moment about n axis, meaning moment about n axis, meaning I will use this equation. To use this equation, I need three things. One is, what is the unit vector of the axis? Two is R from axis to force. Third is F, right? And in this case, okay, nothing is given, so I need to find all the three, right? So let's discuss on the unit vector first. So in this case is UAA, right? Unit vector of AA axis, and AA down there. How many of you can give me in 10 seconds what is the unit vector of AA? Five seconds. Alright, so if you understand, you should be able to tell right away, right? What is the unit vector of AA? What is it? It should be j, right? Right? Because that axis is actually parallel to y-axis. So if I assume it's counterclockwise based on y-axis, then it's j. If you assume the opposite way, it's minus j, basically, right? Okay? So you have to understand those, because we have learned before in chapter 2, right? To get the unit vector, one way is to get the 2 point, get r, get the magnitude of r, and then we divide, you get unit vector, right? But not in every case you need to calculate, because if it's x-axis, it's straight with I, y-axis j, z-axis k, you do not need to calculate. If you calculate, it's still the same. But in this question, you cannot calculate because they didn't give you any coordinate there. So you have to just understand, okay, it's parallel to y-axis, hence j, right? Understand that one. Alright, for unit for r, so from where to where? So it's basically from the axis, because there's no point there, so from the axis there to the point. The point is, okay, there's no label in there, so you understand that from, okay, in a way, basically there's like axis here, right? And then there's something like this, right? In the diagram, and then the force is here like that, right? So what I need is just this r, right? So from the dimension given, so x will be, okay, be careful about the position, right? So x will be negative 100, right? Negative 100 I. Why negative? Because it's from the axis to the point of force, and it's on that side. X positive is there, but the r is this way, right? So it's negative x. Right, so minus 100 I if you use millimeter. If you use meter, then 0.1. Alright. Y is 0 plus 0j, because it doesn't move in that direction. Z is going up 150 plus 150 k millimeter. Alright, so we have already established U, we already have established R. Next is F. What is F? Okay, you have alpha, beta, gamma again. So you have 30 cos alpha is 60, right? I plus 30 cos beta is 60. 60 also. J plus 30 cos gamma is 45. 45 K Newton. Is it Newton? Newton. Right? So after that, you just plug in there, because you already have the equation. Now plug in U, R, and F. So U is, again, what is it? Do not make mistakes. How to put this here? Should be 0, 1, 0. Why? Because 0i plus 1j. Okay, for some student, it helps if you write like this. UAA is 0i plus 1j plus 0k, and then they can actually get 0, 1, 0, right? Because if you write like this, sometimes some students actually write j there, which is a problem, right? Do not lose mark like that, it's so sad. Okay, so in this one is minus 100, 0, 150, and then you have all of this, right? 30 cos 60, 30 cos 60, 30 cos 45, and then you can solve, right? Again, here is 0 minus 1 plus 0, right? And of course you have the bracket here, something minus something, something minus something, something minus something, and then you solve, right? And you have the answer that if you use UA equal to J, you get the answer of 4.37 Newton meter, or in our case it will be 4,700 something Newton millimeter, right? So it means it's rotate in your thumb is J, right? Because it's positive. Alright, so any question, please do ask. And then there's attention quiz, so please try those also, because sometimes the question actually tests whether you are actually paying attention or understand, right? For example here, if you want to find moment of f about x-axis, which R should you use, right? So make sure you try, and if you understand, normally straight away you can understand, discuss with your friend. If you cannot even which one is the answer, please do raise in the class, right? Normally in the class when I ask any question, anything, normally silence, right? So please, if you don't understand, keep note, and early in the class when I ask, just raise and say, okay, to the slide, that slide I don't understand, please explain, do so. Alright, so end of 4.5. Yep, so yeah, I think that's for today. It's already 1:45 in the morning, 1:45 a.m. So we have covered chapter 4 until 4.5 right now. So we have covered moment about point, and in this video we have covered moment about an axis. In the next video we will cover a different moment, right? There's many moments that we have to cover, right? So in the moment like this, okay, so I'm already sleepy. So with that, inshallah, we end the session. Subhanakallahumma wa bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.